Hi, welcome to Concept Based. I'm John Hepworth. This one's for Year 11 Advanced students. We are in the functions section of your syllabus still, and in that section we are now in the direct and inverse variation. So with direct and inverse variation, first of all, something has actually changed in a previous syllabus to this syllabus, which I know doesn't affect you, but if you are doing questions out of an old textbook, in relation to inverse and direct variation, then just be aware that those old questions may not be accurate. Excuse me. Because previously, when we looked at direct variation, it was this equation that we used, and inverse variation, it was this equation that we used. But the subtle difference being is that yours now looks like this. So the x can be raised to a power, which obviously is going to make things look different. So we used to be just dealing with linear direct variation. So now it's nonlinear direct variation. And previously, the inverse variation was a hyperbola, and it still is in essence. But yeah, the power of n can change, which certainly changes the shape of the graph significantly if we're talking about the negative side. However, most of the questions that are asked about this type of relationship or function is that they're practical application questions, and practical application questions typically only go in the positive direction. For example, if you have time as the variable that it's related to, then time's only moving forward, so you wouldn't end up on the other side of the graph. Anyway, so no huge change, but there is a power to x there. And what that power of x there sort of leads to is that I think if I had a crystal ball and I was able to predict what's going to happen in the HSC at the end of next year, I think that this question now really does lend itself to being a multiple choice question. And I think that that will be the complexity that will be in the multiple choice question that will provide incorrect answers that will relate to linear variation, or like a hyperbola power with a power of 1 variation, inverse variation. But it'll be like this question where it's squared, and people will miss that part of the interpretation and therefore get the incorrect calculation. Okay, so there's enough backstory, old syllabuses, and possible, and I suppose future story, potential HSC questions. Let's look at where we're at today. So this question says light intensity is inversely proportional to the square of the distance. If the light intensity from a source at a distance of 5 meters is 200 candela, how much would it be at a distance of 10 meters? So we have to, this is one of the questions that has a fair bit of text in it. You don't see a lot of text in a lot of questions, particularly in Extension 1, but definitely in Advanced as well. But this is a practical application question, so it's going to be a little bit wordy. So we have to extract information from it to make sure that we're building the right model to do this question. First of all, we see this inversely proportional. So that's the one that needs to ring alarm bells for us. We need to understand exactly what we're talking about when we talk about inverse proportionality. So we're looking at a basic equation of this. So if we have that basic equation, we then need to go in and fill in some further details based on what we're asked. So we're then asked to the square of the distance. So light intensity. Now I'm just going to say that light intensity is C, not Y, because it's in the units candela. And then the square of the distance. Okay, so now I'm going to change X to a D calculation because it's distance. And I was told that it was the square of the distance. So those are the things that are changing in our equation. It then says if the light intensity from the source at a distance of 5 meters, so I can actually make direct substitutions now into this calculation. So I might just grab this and move it over a little bit and just do those substitutions beside it here. So now we would get 200 equals K over 5 meters, so 5 squared. So that's a substitution straight into the formula with our 200 candela, our distance of 5 meters, and this was a square of the distance. Okay, so now we've got 200 equals K over 25. And we want to find K. So K is just that constant that multiplies the direct variation or inverse variation. And so it now times both sides by 25, and 25 lots of 200 is going to be 5,000 is equal to k. So we want to find k first, and then we want to find the other case that we're given. So you could sort of think of this as like an initial condition, but it's not initial because distance isn't 0. But you can think of that k as what would happen in the first set of data that we're given. So now we want to actually go and do the question we've been asked, and we want to say, hey, what happens when it's at a distance of 10 meters? So now c equals, now our k has been found, and we're writing 5,000 over 10 squared. So now we have 5,000 over 100, which is going to cancel some things off and give us 50. Now make sure that your answer makes sense. Would we expect that the light intensity to decrease from 200 down to 50 as the distance increases? Yes, we should expect that. That sounds like a correct practical application. And we should notice that it hasn't just changed linearly. It hasn't gone from 200 down to 100. It's gone from 200, even though the distance has doubled, it's gone down by a factor of 4, which is again what we expect because we've got this squared factor in the denominator. And that's it. So that will give us an answer there. Be aware, like I said, this will come in, like the syllabus actually states that you'll be solving problems, and the support document states that it will be things that are like science-based, physics being a part of science. So expect there to be this sort of wordy type of question that might be biology or anything up here. So expect that. It's pretty straightforward. It's also almost exactly the same when you do it just as a direct variation. So it's just the k x to the n example. The process will be identical. You'll find k, and then you'll sub in the new set, and you will find whatever the new solution is that you are after. So hopefully that makes it nice and clear for you.